So in this talk, I'm going to tell you the story behind SQLancer, which is a tool that we designed and developed to automatically test database management systems. Now, I assume that many of you are not directly working on developing database management systems, which is why I will focus on general insights that you might be able to apply on testing your project. So just to ensure that you're all on the same page, in our work, we wanted to test database management systems that expect queries or statements written in the structured query language, or short SQL or SQL. As perhaps most of you knows, we can, for example, use this language to create tables, to insert data into them, and then again fetch data using a select statement. Now, in the previous talks, we already heard a bit about testing. So how can we write test cases that could test such systems? Well, one approach would be to just write them in SQL. We could, for example, specify the test case, such as here, taken from the MySQL test suite, and then in a separate file, specify the expected output. And while there are some frameworks that make this process a bit easier, I would argue that it's still always challenging and time-consuming to write manual test cases, especially considering for such complex systems where we need huge test suites. So in our work, we ask ourselves, can we automate the test process? And this brings us to two challenges. First of all, if we want to have an automated testing approach, we need a test case. And in our case, this means that we need to generate a database and a query that we can then validate. So looking into what's already out there, we can find tools such as, for example, SQLsmith. SQLsmith is an effective and widely used random query generation tool that mutates and generates complex SQL statements that might cause, for example, a crash in the database system that developers can then fix. So I would say that this is already a solved challenge. So we can use either this random generation approach or another one to generate the test cases. Now, what was still an open challenge is the so-called test oracle problem. Namely, we want to validate the query's result. So what's a test oracle? A test oracle is basically the mechanism that determines whether a test has passed or failed. And for regression testing, for writing manual test cases, we typically, as the developers are or provide the test oracle. But this is often difficult, even for manually written test cases. And I want to illustrate this based on a concrete example. You can see here a test case that actually allowed us to find and report a bug in MySQL. You can see here that we have two tables, T0 and T1, each of which holds a floating point value, namely a +0 and a -0. And then we instruct MySQL to fetch the cross product of all records from these two tables, where the column evaluates to the same value. Now, what's the expected output here? I would argue that it's disputable whether the predicate here should evaluate to true or false, because we could, for example, look at the binary representation of these two floating point numbers to realize that the sign bit differs. And based on this, it would make sense that the equality operator evaluates to false, and MySQL for this case would return an empty result. But most programming languages such as Java, C, and so on, they actually define the semantics that this equality operator should evaluate to true for these values. And in this case, MySQL would fetch a row. So at this point in the talk, you have to trust me. Actually, MySQL is expected to fetch the record. But when we tested the latest version of it, it still failed to do so. We reported this as a bug to the developers who then fixed it for the next release of MySQL. But the point here is actually that we could find this bug without having an accurate on whether the predicate should evaluate to true or not, and whether any results or any records should be fetched. We basically had this test oracle that told us that the result returned correct. Now, we actually developed a couple of test oracles. The one I'm going to present today is Ternary logic partitioning, or short TLP. And if I had to explain the approach in half a sentence, I would basically say the idea is to test the database management system against itself. The idea is quite general, so I want to explain it based on an analogy. So if you ever meet in person, it's very likely that this will be in the coffee kitchen, because I like to drink lots of coffee. And let's also assume that there is a bowl with fruits containing both tangerines and also clementines. Now, I'm actually very bad at telling these different citrus fruits apart. They all look the same to me. So this is what I tell you in order to start some small talk. And you might actually respond that you can clearly tell the difference. So I challenge you to show me. But how can I test your understanding of tangerines versus clementines without even having this understanding myself? Well, the strategy that I would apply would be the following. First, I would ask you to please bring me all the clementines, and you would go ahead and fetch perhaps 2 of the fruits. I would then put them back into the bowl, shuffle them around, and then ask you to bring me all fruits that are not clementines. You would bring the apple, which I could recognize, along with the other orange-looking fruits. And I believe that already some of you see where this is going, because you brought me 2 fruits first, and then you brought me 4 fruits, so overall 6 fruits, but there are only 5 fruits in the bowl. Meaning that you likely classified a fruit as being both a tangerine and a clementine. So the high-level insight here is that every object in the universe and also in the bowl is either a clementine or not a clementine. And we use this insight to basically partition all the objects in the bowl. Of course, you could always say, you could always consistently classify tangerines as clementines and the other way around, meaning that we cannot detect all the bugs, but neither can test test cases. So this is a limitation that we have to live with. How do we now apply this to SQL? Now we have any kind of given predicate P and a row R rather than a fruit. Then exactly one of the following must hold. The predicate evaluates to true, not the predicate evaluates to true, meaning that it evaluates to false. And then since in SQL we also have to deal with null values, we have to deal with the case where P might evaluate to null. And based on this, we can now take any kind of data in our table, any kind of intermediate result, and partition it into 3 parts. Namely, those where the predicate evaluates to true, where it evaluates to false, and where it evaluates to null. How did this now allow us to detect the bug from the motivating example? Well, we first generated this query that basically corresponds to counting the number of fruits in the bowl. So we simply fetched the cross product of all values from these 2 tables. And there MySQL returned a single record. Then we generated this more complex 3 queries based on this random predicate P. You can see here that we have the non-negated version, the negated version, and the is null version. Overall, we expected that this should compute the same result. However, MySQL returned an empty result set here, which allowed us to find and report the bug. The technique is actually quite versatile in the sense that we can test multiple different kind of SQL features, here only focused on work losses. So we basically had this random generation approach to tackle this test case generation problem. And now we propose Ternary logic partitioning to tackle this test oracle problem. Can such a simple technique be effective is the next natural question. Well, I used SQL answer, TLB being one of these approaches that we proposed to find over 450 unique and previously unknown bugs in widely used database management systems that you have all heard of or know. And what should you take away from this talk? Well, while the specific technique that I primarily works for data-oriented systems, it is based actually on a more general kind of technique. Namely, if we look at this from an abstract level, we basically can realize that we had a test case that we executed to obtain a result. And based on this, we derived a new test case for which we could then provide a test oracle. And this is metamorphic testing. Now, what you can do is you could try, of course, to come up with a metamorphic testing technique for your use. But an alternative would also be to check if there are any already existing approaches, for example, by looking on Google Scholar. Yeah, and with that, summarize the takeaways. So manually writing test cases is time intensive and requires detailed domain knowledge. And you might actually face a similar problem in your work. So what we propose is to couple random test case generation with metamorphic testing, which turned out to effectively complement manually written test cases. With that, listening.